Hey, mathematicians, this is Mrs. Shopper coming with you with a follow-up to what we did with our Google Meet today about algebraic proof. I just wanted to give you an opportunity to just kind of come back and hear it again. In class, we talked about what is a proof, why do we use proofs, how do they work, and so this is just building off of that a little bit with the algebraic proof. The first thing I want you to do is to pause the video and make sure you get these into your notes. Making sure you get into your notes what you need. All right, some of this stuff you might be okay with, like the distributive property, you probably are feeling comfortable with that. But some of the different pieces of it, these are all rules focused really on reflexive, symmetric, and transitive. Those are new terms. The addition, subtraction, multiplication, and division properties of equality basically says if you add the same thing to both sides, if you subtract the same amount from both sides, if you multiply the same amount to both sides, or you divide both sides by the same amount, you're going to get an equal equation or an equivalent equation. But focus on the reflexive, symmetric, and transitive because those keep coming back. So making sure you understand that this is where, as the studying kind of changes, you need to practice these. You need to maybe ask a parent or a friend to quiz you on them, but making sure you truly understand what these means. This is that extra time that you need to put in to make sure you understand it. So what we're talking about when we talk about proofs is like we said in class, putting together a proof is really like what a lawyer does, right? They take a situation and they try to prove something or the other, and they use specific steps to make that case. We use the concept of proofs all the time. When you're trying to prove to your parents that you should be able to have, be able to go over to a friend's house or to be able to watch a certain movie, you put together a reason why you think that. And that's what a proof is. It's taking something to start with, and then you want to make statements that support each other to get to your concluding part. That's what a proof is, right? So if we put it into something you're comfortable with, like solving an equation, we can go through steps and properties. Now, the one thing I want you to notice is that when we get to putting proofs together, we need to make sure we are numbering every single step. And we'll talk more about that as we build them in. But it's important to us that you understand the idea of what a proof is. We are certainly not doing the number of proofs that we have done in the past, simply because we know the amount of hands-on assistance that you need when you're starting to learn to do proofs. It's really hard to do those on your own. But we are going to give you a little bit of a taste of it, just in familiar terms, so that you understand what those are. So we always start with the first statement is our given. We'll call it an original equation, or most often you see it as given. This is what we're given to start with, all right? And then how do we go about each step? So to go from step 1 to step 2, we apply the distributive property. That was my reason for going from here to here. I distributed the 4, distributed the 2. Substitution property, it also can be called the simplification or simplification. What I did is I combined like terms. I took 10 and negative 28 to get negative 18, negative 6, negative 4 to get negative 10. Justifying what you're doing. For the next step, I added 18 to both sides, which allows me to cancel out 18 on the left. It's the addition property. To get from here to here, I subtracted.
Sorry for the interruption, but I have a set of keys that was brought up to the main office from the front doors. If somebody is missing a set of keys, please come to the front office.
I don't think it's me. Maybe.
Thank you.
Okay, then we did the substitution property where we went, or not substitution, not subtraction, where we substituted this value in for this. The division property, we divided both sides. And then substitution is also, again, simplification. Same thing here. And I might have misspoke a little bit. Simplification. All right. Now, when you go through and you solve an equation like this, do you sit and think through each of that? Probably not so much, because right now it's just kind of like, it's just what you do. You've learned it. It's part of how you do it. And sometimes we don't think about the why we do it. We just do that. And so putting it in a context with something you're familiar with, you can justify it each time if you want to. So we're going to put one together as we go through. So we're going to just write an algebraic proof together. We have our given statement. We need to prove this to be true. Okay? So I want you to write this down on paper. I want you to practice putting this in together. So my first statement is going to be that A equals 1/2 H times the quantity B sub 1 plus B sub 2. So who knows what this is the area of? Anyone? Anyone? Trapezoid. It's the area of a trapezoid. All right, so I'm going to list that and I'm going to say given, okay, because that's my first statement. It's given. Now I need to get to isolating the H. I want to rewrite this equation eventually so H is all by itself. So number 2, I'm going to multiply both sides by 2. So I'm going to have 2 times A is equal to 2 times 1/2 H times the quantity B sub 1 plus B sub 2. Oops. And I'm going to use that the multiplication property. That's what allows me to do that. I can multiply the 2 by both sides. Then I'm going to have that 2A is equal to H times the quantity B sub 1 plus B sub 2. Okay? And that's going to be simplification or substitution. From here, I'm going to divide both sides by the quantity B sub 1 plus B sub 2. So it's 2A divided by the quantity B sub 1 plus B sub 2. And that's equal to H times the divided by the quantity B sub 1 plus B sub 2. And that is going to be the division property. I'm going to simplify again. So I have 2A divided by B sub 1 plus B sub 2 is equal to H. And that's going to be simplification. Now, I am not done yet. I am not done yet because my proof statement needs to be exactly what it's here, and it's not. So which property, remember I had you look at a few of them at the beginning? Which property is going to allow me to switch them? I'm going to use that symmetric property of equality right here because I have to have it look the exact same as my proof statement. So I'm going to switch it around so it looks exactly like this. So H is equal to 2A divided by B sub 1 plus B sub 2. And so number 6 is going to be the symmetric property of equality. Right? Putting a proof together using what we're comfortable with, what we know. Rewriting, okay, this is rewriting functions. This whole process is algebra, right? And we're giving it a little bit of a twist. How can we justify each of our steps along the way? So you'll have some time to work on a few problems. Your given is the hypothesis, your conclusion is the proof. So whether it's written as given, prove, or as an if-then statement, you can turn it into a proof. All right? Thanks for listening. We'll see you next time.